When we think about Earth, we imagine continents, oceans, mountain ranges, and the ever-shifting crust beneath our feet. But far below the surface, in a realm we can't see or access directly, exists a world that has shaped the planet for billions of years. Deep inside the mantle, the vast layer between the crust and the core, scientists have identified two enormous and mysterious structures. They are known simply as the Mantle Blobs, but their scientific name is far more technical: large low-velocity shear provinces, or LLVSPs. These massive internal formations are unlike anything else on Earth, and new research suggests that they may have been central players in multiple mass extinctions throughout our planet's history. The story begins with earthquakes. Every time an earthquake strikes, it sends seismic waves through the planet. These waves pass through layers of rock, changing speed depending on density, temperature, and chemical composition. By the time they reach seismic stations on the opposite side of the globe, scientists can analyze how the waves traveled and reconstruct what lies inside the Earth. With thousands of earthquakes recorded over decades, geophysicists began to notice something unusual. In certain deep regions of the mantle, shear waves slowed dramatically. This wasn't random. It appeared consistently across multiple continents from multiple earthquake events. Using seismic tomography, essentially a CT scan of the entire planet, researchers mapped these regions and uncovered two enormous structures, one beneath Africa, called Tuzo, and one beneath the Pacific, nicknamed Jason. They are truly colossal. They represent about 8% of the entire mantle's volume, roughly 6% of the entire Earth, and rise hundreds of kilometers from the core mantle boundary. From the moment they were identified, one question dominated the conversation: what could have created such massive and distinct features deep inside the Earth? There is no single agreed-upon explanation, but three leading hypotheses attempt to answer the mystery. 1. Subducted tectonic plates. At convergent boundaries, oceanic plates sink into the mantle. Some fragments may not melt completely, and instead remain preserved deep below, eventually merging into larger structures. 2. The remains of Theia. According to the leading model for the Moon's formation, a Mars-sized body called Theia collided with the early Earth. Parts of its mantle may have sunk into Earth's interior and still exist today as components of the blobs. 3. Deep mantle chemical reactions. Minerals rich in iron, especially Fe2+, behave differently under extreme pressure and temperature. These reactions can transform the structure of the solid mantle, creating chemically distinct regions that slow seismic waves. The true origin may be a mixture of all three, or something not yet imagined. But understanding what they do is even more important than how they formed. Earth has experienced 5 major mass extinctions, and nearly all of them, 4 out of 5, are tied to catastrophic volcanic events. Recent research suggests that the mantle blobs play a crucial role in triggering these global disasters. These structures appear to act as deep reservoirs of heat and chemically enriched material, capable of generating massive mantle plumes, enormous lava outpourings, and vast flood basalt provinces. The Permian-Triassic mass extinction. About 252 million years ago, Earth experienced its deadliest mass extinction. 96% of species vanished. This event coincides perfectly with the eruption of the Siberian Traps, one of the largest volcanic events in planetary history. The new study suggests that the blob beneath Africa may have initiated a mantle plume that rose to the surface and drove the Siberian eruptions, triggering runaway greenhouse warming, ocean acidification, and the collapse of ecosystems across the globe. The extinction of the dinosaurs. The famous event that ended the age of dinosaurs 66 million years ago is traditionally associated with the asteroid impact in the Yucatan. But we now know it was not the only catastrophic event happening at the time. The Deccan Traps in India erupted on a scale unmatched since the earlier mass extinctions. Some models propose that the force of the asteroid impact may have disrupted the deep mantle, releasing energy stored in one of the blobs and intensifying the Deccan eruptions. Combined, the impact and the volcanism reshaped the biosphere and ended the reign of the dinosaurs. In short, The mantle blobs may be key drivers behind some of the most dramatic turning points in Earth's history. Surprisingly, these deep Earth structures also have beneficial consequences. 1. Predicting volcanic eruptions. Understanding the behavior and location of the blobs allows scientists to anticipate where mantle plumes may rise and where future large-scale eruptions could occur. 2. Diamond formation. Some of the world's largest diamond deposits originate from deep mantle processes directly linked to these structures. The blobs influence the temperatures and pathways through which diamonds form and ascend to the surface. 3. Rare earth elements. Rare earth minerals, crucial for modern technology, may also be connected to the activity around the blobs. Mapping them improves the ability to locate economically important deposits. In this sense, the blobs are not merely destructive forces, they are also engines of geological creation. The study of the mantle blobs is still in its early stages, but with advances in seismic networks, improved tomography, and computer modeling, scientists are now able to see deeper and with more precision than ever before. These structures provide insights into the evolution of Earth's interior, the cycles of life and extinction, and the hidden forces that shape our world. Far from being simple anomalies, the blobs are central to understanding the planet we inhabit. The mantle blobs are among Earth's greatest geological mysteries, massive structures buried deep within the planet, influencing everything from volcanic super-eruptions to the formation of precious minerals. They are silent, colossal, and ancient, and yet they have shaped the trajectory of life on Earth time and time again. As new research uncovers their role in mass extinctions, volcanic cycles, and the planet's chemical evolution, one thing becomes clear. To understand Earth's past and its future, we must understand the hidden giants within its mantle.